Hello and welcome back to today's lesson. And today we're going to be continuing on from yesterday and think about how when we can compare fractions, that actually means that we can then order fractions. So not only are we just comparing two fractions together, but we can compare a series of fractions and put them into order. Now this works exactly the same as when you order numbers. So if you had a set of numbers, you know that you either start with the smallest or start with the biggest and work your way up or down. The idea is exactly the same, except we might need to use our skills from comparing, i.e. equivalent fractions, in order to know that. Or we can use some of the other rules to get there as well. So let's have a look. So your first question is, can you attempt these, please? Have a look, see what you can do, and pause now and give it a shot. Okay, so the first one is putting the fraction into the correct box, either less than a half or more than a half. So what you're doing is having a look at the numerators and seeing if they are more than a half of the denominator. If they are, then you know it's more than a half. So 4, half of 4 is, half of 6 is 3. 4 is more than that, so it's more than a half. Half of 29, now this is an interesting one. Half of 29 would be 14.5. So 14 and 29 would be less than a half. Half of 4 is 2, 8 is more. Half of 99, this is a difficult one. So half of 100 is 50, so half of 99 would be less than 50. So in this case, this must be less than, or more than a half. It would be less than 50. So 50 would be more, and this would be more than a half. Actually, what is a half of 99 is 49.5. So 50 is more than that. But the way in which to think about it is if 100's half is 50, then 99 must be the half is less than that. So 50 is more than that. In the case of this next one down here, our rule is if our numerators are the same, the smaller the denominator, the bigger the fraction. So we could literally have any number in here that was bigger than 12, so 13, but it could be any number that was bigger than that. Any number at all that's bigger than 12 would be smaller than 11/12. And then we've got our bottom one down here, 11/8 or 10/4. Well, actually, this is easy. You could use equivalent fractions to work this out, and you can compare this into eighths. So we times by 2, so we times by 2, and then you can compare them. That's 20, sorry, not 26. And then you can compare them, which is nice and easy because this is definitely bigger. Or you can think about the fact that if we were exchanging them to mixed numbers, this would be 1 whole and a bit, and this would be 2 wholes and a bit. So this is still definitely much bigger. So write these fractions in order, in ascending order. The thing we need to remember is that if the numerators are the same, which they all are, the greater the denominator, so the bigger the number on the bottom, the smaller the fraction. And if that's our rule, all of these denominators are the same. Okay, so we can then just look at our numerators. And what it says is the bigger the numerator, the smaller the number. So that's being the biggest numerator goes in the smallest one. And then we just use common sense to know we work our way down in size on numerator to order them that way. And this is nice and easy because it is just ordering in the way you expect it to be. It's just you have to remember that when the numerators are the same, the greater the denominator, the smaller the fraction. So when the numerators are the same, the denominators are the same, when the numerators, then we just order as we normally would. Bigger is the bigger. But we don't have our numerators the same, denominators the same. So we have to make that the case. 16 is the largest one, both 8 and 4 go into 16. So what we have to do is think about, okay, 8 needs to times it by 2, times 8 by 2 to get 16. So I must times 5 by 2, that's 10. 4 to 16 is timesing by 4. So 3 times 4 is 12. And again, 8 times 2 is 16. So 2 times 2 is 4. Then we now have them all with the denominators being the same. We can literally just compare the numerators. 4/16 is the smallest. So 2/8 would then go there. The next smallest out of the ones we have is 10/16. So we have 5/8, then 11/16, and finally 12/16. So it's just using the knowledge we had from yesterday, equivalent fractions, in order to compare numbers. And actually, all of you, every single one of you, can compare numbers. Each of you can tell me whether 4 is bigger than 12 or 12 is bigger than 10. You can all do that. So as long as you know you can use equivalent fractions to find the same denominator, you can always order fractions. So have a think about this one. What of those denominators do all the other denominators go into? Then work out your equivalent fractions, then compare. Give it a shot. Pause now. Okay, so all of these, 2 can go into 10 and 5 can go into 10. So our common denominator that we're going for is 10. In order to get from 2 to 10, I need to 2 times by 5. So I have to times the top by 5 as well to get 5/10. 3/10 I can leave as is because we've already got a 10 on the new denominator. Then to go, we have to times 5 by 2 to get to 10. So we must times the 4 by 2 as well to get 8/10. Times the 5 by 2, so the times the 2 by 2 would be 4. And then we just compare the numbers that we have on the denominator. Smallest, it says down this end, greatest down this end. So the smallest out of 5, 3, 8, 4 is 3/10. And you can just see, you just order it round the same way. So 3/10 goes there, 4/10, 5/10, 8/10. They are the corresponding fractions. Okay. So finding equivalent fractions, just a recap, here's what we did before. You find out what you do to 1. So if I times the bottom by 3, I have to times the top by 3 as well. So 3 times 3 would be 9. Vice versa, if I've got the fraction 9/15 and I'm coming down to 5, I know I'm dividing by 3. If I'm dividing the bottom by 3, I need to divide the top by 3, so 9 goes to 3. That's how we find equivalent fractions, and that's what we're using to do this. Now, this is slightly harder because we don't know what is going on here. Now, we can think about putting them in terms of 16ths, which is probably 16 on the top here, because 8 can go into 16, and so can 2. That's the only way we can compare these. And when you look at what it goes through, that's what we're kind of looking at. But in my head, the easiest way to do that, we'll do it together, is this other way. This is quite tricky. Okay, so don't worry if this is the bit you trip up on. What I really, really want you to be able to do is the first 2 parts. Order and compare numbers using the way that we've just done it. That's the most important bit. Get those done and you should be in a good place. Use the skills from yesterday's lesson. But let's have a look at this one. So 13 doesn't easily go into 23. Doesn't happen. You could do 23 times 13, but that comes up with a really big number and it's just not worth it. But what you do notice is 8 does go into 16. Okay, so let's have a look. 8, I'm going to make an equivalent fraction with 16 on the top. So what have I done to 8 to get to 16? Well, I've times it by 2, which means I need to times the bottom by 2 as well, which is 26. So I've got that, that's all worked out for me. Yeah. Then I've got 2 here. I need to put that in terms of sixteenths. So 2 in terms of 16. Now, the other thing I need to know is that this 2/16, this 2, whatever it happens to be, this missing number bit here, this needs to sit in between 16/23 and 16/26. So we could use, there's 2 numbers we could use. We could use 25 or 24 because that's in between 23 and 26. And we could use any of them. Probably the easiest one to use. We could try it and see, but let's try 24 and see if it works. So if I put 24 in there, what do I have to do to get from 16 down to 2? Well, I divide by 8. So could I use 25? Well, 25 divided by 8 is not a nice number. 24 divided by 8, on the other hand, that is a nice number. 24 divided by 8, sorry, is 3. So the number I'm missing over here is 2/3. Yeah, because it fits in this order. This one is the biggest, same denominator, smallest, same numerator, smallest denominator. So this would be the biggest. Then I've got 24 on the bottom, and then I've got 26 on the bottom. So they're in the right order, this one being the smallest, one in the middle, biggest. And the way I can do that is to put 8 in terms of 16, times it by 2. That gives me the bottom number of 26. Then I know that this middle number, when in terms of 16 on the top, must be either 24 or 25 to make sure it's in the right order. So 16 over 24, 16's relationship to 2, because I know that's the number, it says it here, is divided by 8. So I can't divide 25, so I can't use that, but I can divide 24 by 8 to get 3. That's why it comes up as that. And you'll see the way they do that. That one doesn't work. 24 does, and that makes 2/3. This is difficult, but it is just using the rule that if your numerators are the same, then the smaller the fraction has the larger denominator. It's also using your equivalent fraction rule a lot. So really get used to that equivalent fraction rule. Whatever you do to the top must be done to the bottom. As long as you remember that, you stand you in good stead. So here, now it's your turn. Have a go at questions 1 and 2 for me. Pause now and have a go. Okay. And here are your answers to 1 and 2. Let's have a quick look through it. What could the missing numerators and denominators be? Write a number in the box to make sure. Now, there are multiple answers you could have. So these aren't all of them. These are just an example of them. But as long as you're working through thinking about your how you're doing it, it shouldn't be a problem. So if I've got 5/15, that's one of my numbers. That is greater than whatever this number here, which is 1/5. Now 1/5, if I'm going to put that in terms of 15ths, or whatever this 5 in terms of 15ths, I'm timesing by 3. I've got to make sure it's under 5. If it's over 5, then this would be bigger. So if I put a 1 here, times that by 3, that would be 3. That would work. If I put a 2 here, that would be 4. That would be 6. Does that work? No. So the only answer we can have in this case is 1/5. So our answer is 1/5. And that's how I would do it for all of these. It's all related to how you think about the way in which you put it together. Let's have a look at another one, and let's go with the first that looks like this. We've got 6/9, and we're saying that is smaller than 5 somethings. Now, we can keep these fractions under 1 which means we could put it as 5/5. We put it as 5/5. This is 1. That means nice and easy. Or we think about what other number we could have here that would mean that this is bigger than that. And there's a few ways you can think about this, but the easiest way to think about it is, numbers that work alongside each other. This is bigger than this one. So if this one needs to be bigger than this one, whatever the number here is needs to be smaller than 9. And then you would have to try it and see. So because we're going to be comparing fractions, let's think about numbers we could use which would be in this, which are under here. So it needs to be a number that's bigger than 5, so 6, 7, or 8, and smaller than 9, because if it's bigger than 9, it's definitely going to be smaller. So it's going to be one of these. We try the first one, so let's put a 6 in there, which is the answer, but we'll go through this in a minute. Then we need to compare these. So we need to work out whether this is bigger than this. Well, when looking at this, the way to do it would be to look at what's our relationship here. So what we can do is see what the relationship between these two numbers are and what number both of these two numbers go into. Both of these two numbers go into 18. Both of them go into 18. So what we can do is put them both in terms of 18. 6 9s in terms of 18 and 5 6 in terms of 18. The reason I picked 18 is because I know both of these two. This times 2 is 18 and this times 3 is 18. What you could do is just use 6 times 9. 6 times 9 is 54. So you could put them all in terms of 54ths and think about it that way. The easiest way to think about it is to think about your lowest common multiple. So you go through your 9 times table and you do 9, 18. You can continue on and you do 6, 12, 18. The first number that appears in both times tables you can use as your common denominator. So 18 in this case is both the same ones. What I've done is times it by 2, so I need to times that by 2. Times this by 3, so I times it by 3. 15 18ths is bigger than 12 18ths, so this is true. If I was to use any of the others, it possibly could work, but again, it might not do. So if you find the right one, stick with it. On the other hand, we've got it over here. We've got Tommy and Abra comparing fractions. They've got 2/3, 8/12, and 4/9. Tommy says, I found the common denominator of 36 to compare the fractions. What he's done is worked out all of these are into 36. Whereas Ava said, I found a common numerator of 4 to compare the fractions. All of these can be put into 4. This one here, and the reason whose method is more efficient, this one here requires more maths work. It's easier to think about, but it requires more maths work because you have to times each of these fractions and find equivalent fractions for all of them. Whereas finding a common numerator of 4 is quicker because one of them already has it. And then you can just compare across it. So she could keep the 4/9 as one of them. In order to get 4 on the top for 2/3, so 2/3, I want a 4 on the top. I've times that by 2. So that means I need to times the bottom by 2, and that makes 6. Then the other one, I've got 8/12. I want to put that the 4 on the top. What have I done 2/8 to get to 4? Well, I've divided by 2. So I've got to divide the bottom by 2, which is 6. So I've got 2 that are 4/6 and 1 that's 4/9. Well, 4/9 is smaller, so you know that this is easier. You only have to do 2 calculations with this one, whereas with Tommy's method, you'd have to do 3. So Eva's is quicker. Here's some more questions. Fractions in ascending order, which means you start with the smallest and go to the biggest. And then question 4 with what could be the missing numerator. And remember, this, I've said write all 4 possibilities down, but this is the hardest question there is. So try your best, see how you do. Pause now. Okay, so your answers. The first one, if you look, all of the numerators are the same. So the smallest one is going to be the one with the biggest denominator. Then that gives us that one. Then the next biggest, then the next biggest, the next one, and the next one. Because we are comparing numerators, it goes the wrong way because our denominators, because our numerators are the same. In this case here, we've got lots of numbers along the bottom down here, and we need to put them in terms of one or the other. So we could put them in terms of threes, but that's hard in the case of the ninths here. Or we can put them in terms of ninths, or we could put them in terms of eighteenths. They all go into eighteenths. So you could put them in terms of eighteenths and work from there. If you, any of those that you work along, you are thinking about where it comes. What I would actually do is work out what 2/3 are as a fraction in ninths. That will give you an idea of where that would go. All of these, if you look at 2 ninths, that's quite small. 5 ninths, only just over 2 ninths. So what I would do, I would pick the highest ninths, the 2/3, and the 5/6. I know that these two are going to be my smallest, more than likely. This compares the largest ninth I've got. And I would put, first off, I do, okay, so 2/3 compared to 5 ninths. So in order to put that as a ninth, I need to times by 3, times the top by 3 here, gets me 6. 6 is bigger than 5 ninths. So first off, because I've done that first one, I know that I've got 1, 2, 3, 4, 5. 1, 2, and 5. They're all done. That only leaves me with 2/3 and 5/6. So I can then just compare those two left over ones. So 2/3 I can then put in terms of sixths, times it by 2 there, times the top by 2, which is 4. That's smaller than 5/6. That tells me where it goes. And that would be the way I'd go about it. I wouldn't do lots of complicated maths. This involves 2 that I would do. Here, our common denominator is going to be 10, to put them all in terms of tenths. So 3/5 times it by 2 would be 6/10. Got 7/10 there. A half timesing it by 5 would be 5/10. Got 3/10. This is 1/5, which is 2/10 because of timesing by 2. Then you know you've got 1/5, which is 2/10, then 3/10, then 5/10, which is a half, then 6/10, which is 3/5, then 7/10. This one here is interesting because of this one here. So it doesn't lend itself very nicely to finding the same denominator. So instead we look at our numerators. This number will go into 12, this number will go into 12, this number will go into 12, and this number will go into 12. So we just make them all have 12 on the top. In order to get 3 to 12, I times by 4. So 8 times by 4 is 32. Then 6 times by 2 is 12. So I've got times 17 by 2, which is 34. Got that one with a 12 on top, so I don't need to worry about it. 2 times 6 is 12. So 7 times 6 is 42. Then, sorry, my mind's gone blank. Then 1 times 12 to get 12. So it'd be 12 timesing by 12. 3 times 12 is 36. And then I can compare the bottom numbers. The smallest one is going to be the largest. So that's my largest. And the largest one, which is 2/7, is going to be my smallest. So that's my smallest, goes in there. Then that's 42. So after 42 is 36. That's the third. Then I'm left with 30, 34, and 32. The largest being 34. So that one goes in. Then I've got 32 and 30. So 32 goes in. Then the 30. You got your order. And this is saying what one goes between them. We're looking in 15ths. So we might as well think about these two in the possibility of 15ths. We know that. because a possibility comes in 15ths as well. So 5 as a 15th. I've times there to get to there. I've times by 3. That means I've times the top by 3 as well. So 3 times 3 is 6. Then this one to get to 15. So the easiest way to think about this is in different ways, but this we can think about. There's 2 ways to do it. You can times this by 3 to get 30ths. Times that by 3 to get 27. Then you can times this one by 2 to get 30ths and go from there, or you could half this one to get to where it needs to be. And that will give you 14, which then gives you the answer. Well, not 14, 14.5 gives you the answer to where you can go from there. The other way to go about it, in terms of fifths, you at 15ths, you then think about what that is in relation to these. You've got 6 here, 6 15ths, and this is your smallest one. So you could do that. Or if that's confusing, 3 and 9 you can compare. So don't worry about this one. Well, you need to be able in terms of 15ths, but 3 and 9 you can compare. Look, so you could have the same number on the top and then think about the numbers underneath, which would also give you this way. I would do it the way I've done it, and that will give you these answers here. In theory. So 10 ninths, I can put that in terms of fifths, which would be 4.5. You can never have a fraction with a decimal on top, but this gives us an idea. Then we're timesing by 3, so on 15ths here, 4.5 times by 3 would be, so 4 times 3 is 12, plus 1.5, so 13.5, which gives us that. This is times by 3, so that's 9 15ths. So any number between 9 and 13 would work. And there we got those there. That would be probably the easiest way to do it. But you need to have an idea of these numbers here, which is slightly harder. This way is the hardest question because of those there. You could put those in terms of 30ths and come down from it. But again, that's relatively hard because you're still going to have this decimal number here in order to compare them. But at least that does give you an answer that gives you these answers here. Don't worry about too much about that last question. Well done if you did get that last question. Like I said, that is the hardest question that you're ever going to be asked in this case. And you really have to think about the way in which round you do it. Even I have to think about the way to explain it in the best way. And that's quite hard when you're thinking, what way would be easiest for you to do? And thinking about the maths involved and not making it too complicated. Because what you could, in theory, do is make them all in terms of 30ths. They would all fit into 30. Then you can compare them and then bring them back down to 15 by dividing them by 2. But that gets complicated. And you can't have decimals on top. So you could do it that way and then realise that 26 30ths works and 24 30ths works and 22 30ths and 20 30ths works. Then you can halve them down to 10 15ths, 11 15ths, 12 15ths, 13 15ths, which is one way to do it, or cheat a little bit and use decimals on top. Good luck. I hope at least 1 and 2 were okay for you. 3 is okay as long as you think about it, and 4 is your challenge. Thank you very much. I'll see you in the next lesson. Goodbye.